I'm going to show you binomial distributions. Now, something that's binomial means there's two choices. It's like true or false, pass or fail, 0 or 1, whatever. I like this stone 2. Get it? It's almost like a 1, 2. I thought it was sort of binomial-ish. If you look at this right here, the way we write a binomial distribution, there's a formal way to write it. So we can actually say that, this discrete random variable, if we say it can be approximated by a binomial, we write it like this. We say b of n and p. This is how we write it, okay? Where n is a number of trials, p is a probability of success. So what we do then is we write it like this. This part right here is not really needed for the syllabus here, but it's still nice to sort of see how it's done. At least in the SL, you don't need this. But we could say, the probability of the discrete random variable being equal to r, which is the number of successes, it's going to be, we use this NCR notation right here, right? This combinatorics. P to the r 1 minus p, which is sometimes known as q. It's like the opposite. It's the probability of not success. And was it n minus r? I think it is like that. Yeah, I think that's it. So the only part we really need to recognize is just that if something can be approximated as a binomial. So we say it's a binomial where there's n trials and p is a probability of success. This is really the part we need because our calculator is going to do this for us. Now, it's not always obvious that something is binomial, so it's not just like they tell you it's binomial. Sometimes, they'll say this thing is, it passes if it's got a mass of greater than something. So, well, you got to think that's actually pass or fail. So that's actually binomial. You see, anytime you can think about some probabilities, that's the key. So here's a little pro tip that I like to give is that I use binomial basically if I'm not sure what to do in a question. When we're repeating something a bunch of times and the question asks for like exactly 5 successes or, more than r successes or less than r successes, something like that. If it's used like that, that's when I use binomial distributions. Now on the TI Inspire and the TI 84, they call it binom PDF. I can't remember on the Casio, I think it's like BCD and B, something like that. So they use a short form, but it's very similar. But when to use binomial PDF, well, we use binomial PDF. This is the key one right here. I use binomial PDF. P means exactly. So if we're looking for exactly r successes, then we use binom PDF, where we put in n as the number of trials, remember? That's the number of trials, the number of times we'll repeat this experiment. P is a probability of success. Right? That's the important thing here, is the probability of success. And here we're looking for r successes. So that's the number of successes we're looking for. So if we say like, hey, what's the probability of getting exactly 5 successes? And we repeat this 22 times and the probability of success is 0.2. Then you put in binom PDF and away you go. So remember, this thing tells you a probability. Okay, that's the key thing. So binom PDF tells you a probability. On the TI Inspire, you go calculate menu probability and you put binomial PDF. On the 84, you go distributions, which is second vars, and you just scroll down and find binom PDF. That's how we use it. Now we have another one called binom CDF. So this is the key here. You have to know which one to use when. This is the key here. This one here still tells you a probability. Okay, it still does that. And this one here is still the number of trials. This is still the probability of success. So you might wonder what's the difference between these, right? This here is the number of successes. That's what we're looking for here. Okay. However, the big difference here is this CDF. C stands for cumulative distribution functions. It's cumulative. What that means, it tells you up to r successes. This is the key thing right here. This is the key distinction. Okay, this is it. So what we mean by this is that if I say like, I don't know, let's say I'm looking at the probability of 0 successes plus the probability of 1 success plus the probability of 2 successes plus the probability of 3 successes, for example. So then I would stop at, if I said binom CDF of 3 successes, that would mean give me the probability of 0 successes plus the probability of 1 plus 2 plus 3 and stop at 3. So really that's the difference between these two. One is if you want exactly the number of successes, I want exactly r. The other one is up to and including r. That's it. And again, we get to it by the same way, except we just go binom CDF instead of binom PDF. So let's look at an example. No, never mind. I have something else to show you here. We have something called the mean and the variance. Good news, these are actually on your formula booklets. The mean. So if we have a normal distribution and we're asked for the mean, well, the mean is actually the expected value. It's just n times p, which is actually kind of handy. And if we want the variance, well, the variance we call it var, like this, variance. And it'll be just n times p times q, but sometimes we rewrite it as 1 minus p like this. These are your two different things on your formula booklet. So in case you needed to know the mean or the variance, here's how we do it. Now, I think it's going to be important to consider an example. I think that'll be useful. Let me just write this down. I'll say formula booklet, because I just want to make sure that we have this so that way you know that this is on your formula booklet. You don't have to memorize these in case you need them. There they are, both of them. Let's do an example. I think this will help to put things into context. So we're going to assume that births of boys and girls are equally likely. So that means right away, before doing anything else, that means the probability of a boy equals 0.5. That means the probability of getting a girl is 0.5. Okay. So what's the probability that in a family of 6 children, all the children are girls? So we have to think about this now in terms of binomial. Is this binomial? Well, yeah, they're either girl or not girl. Do you see that? It's either a girl or a boy. So in that case right here, it's binomial. All right, so if all the children are girls, what does that mean? Well, there's 6 kids. So it's really important to consider what these different values are, because both binom PDF and CDF need to go n, p, and r. So we need to know that. So what's n? N is the number of trials, so the number of times you repeat the experiment. Well, in this case, there's 6 kids, so n will be 6. How about this? Probability of success. Probability of success. In this case, success will be to have a girl, so I guess that'll be 0.5. Okay, so p will be, so p equals 0.5. See that? The probability of a girl is 0.5. And n is 6. Now r is going to vary. It's going to depend on the question. So let's look at this now. In this case right here, we want to know all of the children are girls. If they're all girls, how many girls are there? Do you see that there's exactly 6 girls? I want to know what's the probability of having exactly 6 girls. Well, think, is that binom PDF or CDF? PDF is for exactly r, so that's the one I want. So I'm going to write it down. I'm going to say, good. That means I want to do binom PDF. And I'm going to put in for n, I'm going to put in 6. For p, I'm going to put in 0.5. For r, I'm going to put in 6. So what are these different values again? This is n, this is p, and this is the number of successes, so r successes. Let's do this on the calculator. We'll see. We'll figure that out in a second here. So let me get out my good old calculator. Boop. And I'll go to menu, and I'll go to probability, and I'll go to distributions, and I'll say I can scroll down. Can you see this binom PDF there? Number of trials, 6. I want the number of probability of success, 0.5. The x value, in this case instead of r they call it x, but it's still fine, it's 6. So I say go, and I get 0.0156. So I'll say that. So 0.0156. This will be my answer. This is my probability. Does that make sense? It's not all that likely. Look, it's only 1.5% likely or 1.6% likely to get all 6 girls. Well, I mean, hopefully that makes sense. It's not terribly likely to have 6 girls. You have to have no boys at all. All right, what about up to 4 girls? What does that mean? If we go up to 4 girls, that means we can have probability of 0 girls plus probability of 1 girl plus probability of 2 girls plus probability of 3 girls plus probability of 4. This is what I want. Now I could do it with binom PDF and just do binom PDF with 0 girls and find out that answer and add it to the answer for this one for 1, add it to the answer for 2, add it for 3, add it for 4. That's a lot of calculations. That's why instead I like to use binom CDF, because it does it all for you. Because binom CDF does up to and including some value. So watch, I'm going to binom, CDF. That's going to be the difference here, okay? The difference here was PDF for exactly. Because I want it exactly. It's this. This is up to. That means it's going to be a CDF here. That's the key. All right, and what am I going to put in there? I'm going to say, well, give me it for 6.5 and 4. Now, what is this again? Remember the first value right here. This is N. This is P. This is up to our successes. All right, so I want to know what's this. So this will tell me the answer all in one go, which I think will be really handy. So I'm going to go up and find it again. Menu. By the way, you could have just gone over here, grab this thing right here, and just call it C. So you could actually just go up here. You can grab it if you want. There's a way to sort of cheat. You can go back over here and change it to a C. That's one way to do it. You can just change it to C. It'll know. But let me do it the quote-unquote proper way here. So let me just, I'll just clear that. So I'll go to menu. I'll go to probability. You can also get to it by statistics, by the way, under distributions. See, they got probability. Distributions, and I want binomial CDF. It asks me then what's the number of trials. Well, I'm going to say there's 6 trials. Probability of success 0.5. Lower bound I want 0. Upper bound I want 4. So I want to go from 0 to 4. Give me that. Do you see it's 0.89? That'll round up to 1, so 0.891. Okay, so that'll be 0.8. Whoops. Was it 0.089? No, 0.891. By the way, this is approximately equal to. Approximately equal to 0.891. There we go. So this tells us, yeah, it's pretty likely that there's going to be either 0 girls or 1 girl or 2 girls and so on. So do you see this is sort of how we can do this one. So it's 0.891. All right, what about probability of more than 2 girls? That's a little bit harder. See, this one's a little bit sneaky. That's why I put this one in there. So there exists, I mean, there's probability of 0, there's probability of 1, there's probability of 2. I'm just writing down everything that could happen. There's probability of 3, then we could have a probability of 4, we could have a probability of 5 girls, we could have a probability of 6 girls. This is all the different probabilities that could happen. And probability of more than 2 girls, what does that really mean? Well, more than 2 girls means this. It's either 3 or more girls. This is what we want. We want to know this. Now you could say that, I mean, your calculator can actually, your TI Inspire can actually do this directly. TI-84, you have to be a little bit circumspect about it. Let me show you the circumspect way, the weirder way to do it. So you can say, well, if I want to know how much it is for more than 2 girls, I can go from 3 to 6. I can't really find that with normal CDF, you would think, so I have to do binomial CDF of this. I'll take this value right here, so up to 2, and I'll just do 1 minus that probability, and that'll give me this. Do you see what I mean? So I'm going to try to just find what it is for 6, 0.5, 2, where this is the number of trials, this is the probability, and this is R. The reason I'm doing this, that's going to get me this value right here. That's going to get me that value. So if I do this way, let's see here, that's binomial CDF. So I'll go up here, grab me my binomial CDF. I'm just being lazy here, and I'm going to say, give me go from 0 to 2 instead. So this right here gives me 0.344, let's say. 344. Now what do I really want? Well, what I want is the rest of it. So I'll go 1 minus 0.344. That'll give me my answer for this. See, because I figured out this probability here. Well, 1 minus this gives me this. So that was one way to do it. So I can say, give me 1 minus the answer. And I got 0.656. This will be approximate, of course. And that right there will be my answer. This will be my, I'm done. So that was one way to do it. If you use a TI-84 or some of the other ones, that's usually the way to do it. You have to do like 1 minus, this piece here, and that gets you that. However, the TI Inspire lets you do it all at once. I could have done the whole thing all at once. I could have said, let me show you here. Let me just get out. Let me just show you. I could go to, probability, go to distributions, and I can say, hey, give me binomial CDF. There are 6 trials. The probability of success is 0.5. But watch this. I could just say, give me it from 3 until 6. Do you see that? That gets me from 3 to 6. Do you notice then this should give me the exact same answer? Well, luckily that's how probabilities work. So if your calculator can, you can do it directly. If it can't, then you can do it like this by doing 1 minus the CDF. That's it. That's how you can do these things with binomial distributions.